Okay, and last week we had an introduction to this Python visualization library called Altair. So we explained, say, why we choose Altair, what it can do, and also in comparison with other Python visualization libraries, and what are the differences and similarities, like the matplotlib and the Seaborn, and what are the unique things that Altair can do. And also we start with the simple examples of how to write some simple code to create visualizations in Altair. And then, as you can see from the examples, it actually follows very similar kind of concepts like the markers and channels and the visual encoding or the visual mappings, similar to where we covered in the first part of the module. Okay, and then today we're going to talk a bit more about Altair, and particularly about the data and encoding. So the data will be how do you treat different type of data and attribute type, and the encoding, how do you map the attributes to different channels. Give me 1 second. Okay. Yeah, and just as last week, and we'll have some like live coding sessions as well. And it seems to be working in Visual Studio Code now. And if you watch the video or was in the lecture last week, you can see I initially tried in Visual Studio Code, but it runs, but does not display the visualization. And now it seems to be working. Anyway, and so we start with data before we move on to encoding. And then, so as you are familiar by now, so we always need to specify what data to visualize. And it doesn't really matter, it's Tableau or Altair or any other visualization libraries. Okay, and then in Altair, and each top level chart object, which we mostly just use the chart so far, and we will cover layered chart and v-concat chart, which stands for vertical concatenated chart, which that means how they have multiple charts in a dashboard type of view. Anyway, and we'll accept data as its first argument, and we'll see examples very soon if you don't remember from last week. And the data set can be specified in a few different ways. And first as a pandas data frame, and this is what we did last week. And again, we'll see some examples later on. And also, we can, as a object such as URL data, in the sense you don't specify the actual data itself, you give it a path. This can be either a URL on a different website or a local file path, and or inline data, where inline data will be actually providing all the details and kind of similar to the data frame. Okay. And then finally, and you can use the URL string to files. This can be a JSON file or CSV file. So the JSON file and CSV file are the two formats, and I think Altair can support natively, and it can potentially support other formats as well. But you either have to write raw code, you have to do some pre-processing to convert them into JSON or CSV first. Okay. And then this is something maybe a bit more unique, and at least I'm not aware available in other Python visualizations, and is to support the geo interface. So this is coordinates related to the map. And so particularly GeoPandas and GeoDataFrame. And so usually this goes beyond just the longitude, latitude, and which can be easily treated X and Y axis. And I think later on you will see examples, because the Earth is actually not flat, it's a sphere. And when you draw at the global scales, you have to take that into consideration. So that's why when you see a word map, it's not a square or rectangle. And this is where, say, if we're just using X and Y axis, it might not work properly. Okay, anyway, and so we're going to do a first example, and which is using the data frame, which is very similar to the one we did last week. And so to first import Altair, and this is, we'll give it a, say, a short name or acronym. So alias called ALT, which is first three letters of Altair. And then we also need import the pandas and library or package, and we'll give it a alias called PD, just a bit shorter, easier to write. Okay, and then you define a pandas data frame. And so this is not specific to Altair, it's just general how do you use pandas, using data frames in Python with pandas. And this is how you create, so the PD will be the pandas library dot data frame, and this is actual data. You have two attributes, X and Y, and X, you have an array, which including a number of letters, and in the Y, it have an array, another array, which is a number of numbers. Okay. And so this is actually how you draw. Again, it's very similar to what we did last week. You say Altair, which is the Altair itself, and you do chart, as we said, and this is one of those top level objects. These are the other ones mentioned. And it takes data as a direct input and as a, so that's this one defined here. So we'll take this like 2-column table, if you can. And also mark bar, so that specifies the mark. There's other different marks you can choose, points. I think we did the points last week as well, and other common ones. And we'll have a bit more, cover this a bit more later, I think next week. And finally, say the encoding. And so then these are the different channels you can define. So there's a series of different channels. So besides X and Y positions, there's size, there's color, etc., etc. And then these are the channels. And this is the different columns in the data set you want to map to the particular channel. And so in this case, they have exactly the same name. So you will say X equal to X, whereas the first X means the channels can be used for validation. So this is predefined. And then this X is mapped to, it refers to this X here from your data as the, let's say, the name for the attribute or for the column. And similarly here, and you say Y equal to Y, which is the first Y is the Y position. The second Y is the Y attributes here. So that means the Y should map to this. And so you have a visualization, something similar to this. And the X map to the X, you have the A, B, C, D. And the Y map to the Y, then you have 5 and 3, 6, 7, and 2. And in this case, because we choose mark is the bar, so you have 5 bars. And if you say mark point, you will instead have 5 points as these different places. Okay, and I can just do this quickly in the Visual Studio Code. Let's see, hopefully it still works. Okay, let me close these. Let me move this out of the way. Let's just open a new place. And this will be week 9 demo. Okay, so I'll create a few, but I'm gonna do a new one. Altair 2. Okay, so first we need to do the import. See, import. Okay, I'm gonna run these. User bin. And this one. Okay. So hopefully you can see this clearly. And is the text big enough so you can see? Okay. Please let me know if the text gets too small and you can't, it becomes difficult for you to see. Okay, and so I run these two lines first, just import, I run them. You can see a little tick here, that means it runs okay. Okay, and so that will be fine. And then I'll add another cell. I'll break this down into several cells. And so can know if there's error, which part of the code is causing the problems. And next one, I'm going to just define the data. Yeah, actually it knows better than me, data frame. I'm gonna have two, okay. And just to make it clear, so instead of X, this time I'm gonna call it A. And then, okay, maybe I'll do capital here as well, just before. A, B, C, E. Okay, and so that's our first column. Don't need the information. Okay, and I'm gonna do a second column. I'm gonna call it B. And here I'm not calling Y, just say later on you can see why it's not allowing me to get B. And it's a bit easier in the second part. And so 5, 3, 6, 7, 2. So the actual number is not critical. I think the most important thing is make sure you have 5 letters here, then you need to have 5 numbers here. Otherwise, you will not be able to match. Can I run this one again? Okay, it says okay, completely fine. And finally, I can define my chart. And so out. So this is for the short for the Altair here, and dot chart. And you have to say what's the data you're going to use. So I'm going to using data, which is this one defined here. And I say mark will be bar. So I'm going to using bar chart. And then define the encoding. So this is the mapping from the attribute to the different channels. Okay, and here will be slightly different. I will say X equal to A. Okay, so the X will be the X coordinates in the visualization, and A will be this attributes of column in the data. And because I changed this from X to A, so it's clearer. And I say Y equal to Y. Not Y, B in this case. Okay, now let's see, let's run this. Okay, it's working now. And so you can see this creates a visualization just as we would expect it, and very similar one here. And you can easily swap. You can say Y equal to A and X equal to B. And if you run this again, and you get this way. So now the X is on this side and Y is on the, sorry, the B numbers are on the X-axis. And also, for example, you can change, say, from marker to bar to marker to point. And if you run this again, you can see now instead of having bars, you have the points, and you can change this to different marks, etc., etc. Okay, and so this is, I mean, more or less just a kind of review of what we did last week. We had a very similar example last week already. So today we're just going into slightly more details. Okay, and back to the slides. Okay, so one thing we didn't really cover or mention is actually here, and Altair actually use the data type information provided by pandas to automatically determine the data types required for the encoding. So you don't have to specify what is the attribute type for X or Y, and Altair will automatically try to guess that just by looking at the data. And so they will treat this one as string or text and this one as numbers, which is correct. But you can always override that later if you want. Okay, and then this is the second way, and we are creating exactly the same, using the same data to create the same visualization. But the only difference now is this time we are using JSON data format instead of using pandas data frame. And to do this, we actually don't even need any extra library, and because Altair itself built-in processing or handling of JSON file. And so we only import Altair and we'll create the data. And this time we're going to be using Altair.data. So we're going to be using the data function inside the Altair itself. And it says values equal to, okay. And so this is the kind of common format for a JSON. And what it is essentially it's an array. So you can see these two square brackets means it's an array. And inside array, each element is a JSON object. And you can tell this by they have this curly bracket, the beginning and end. And each JSON object has two attributes. One is called X, and the other one is called Y, and it has their values. And so this is actually exactly the same data as we have here. It's just written in the JSON format, and this is slightly longer because for each JSON object, you repeat the X and Y. Whereas you, in the data frames, you don't need to do this. Okay. And also, and then you can charter the data. The code is very similar. You actually don't need to say whether this is JSON or pandas data frame. You still just say chart data, and Altair will automatically figure out what's the right data format to use. And mark bar and encode. And the difference here is, and we'll say X equal to X, column, this is not a 0, and this is a big O. And so if you compare this one with this one, you can see here, just it only says X equal to X. Here we say X equal to X column 0, sorry, column O. I'm making mistakes as well. So what is here is actually specifying the data types as well. So you could leave out this part and let the Altair to figure out what the data type is. And in most cases, it will be correct. But you can also specify yourself. In this case, a big O is a shorthand for or type for ordinal data. So if you remember, ordinal data is, or sometimes also called categorical data. And then this one is, again, similarly, we said the y-axis in the validation will map to the attribute y in the data, and the data type will be Q, which is quantitative, stands for quantitative. Okay, and the pictures you get here is still exactly the same before, and because the data is the same as before, just in the different formats, and the visual encoding again is the same. And the only difference is now in the visual encoding, we also manually specify the data types. Okay, and you can see here, so Altair cannot infer types from a data object. Okay, and so if you define this as a data object using Altair, like a JSON array, and Altair cannot infer data types, and so it will not be able to do this automatically for you. So we must specify them manually, and we could try. If we don't specify, what happens? Okay, and here, as I mentioned, these are the shorthand to specify data types, and later on we'll see So again, just make sure this is not a 0, this is a capital O. As for ordinal data types. Okay, I'm going to give this a go. So I think we should be okay now. We just need to define a new data. Okay, just to save a little bit of time, I'm not going to type these in again. And I'm going to copy them here. Okay, and I'm going to call them different name because I already used the data before here. I'm going to call it data2. And I run this cell. Okay, it says tick. Okay, 0.2 seconds. So now I have data 2. And once I have data 2 and can try to visualize it, I can say out. And I didn't do the import because I already imported early on at the very beginning and run this cell. So now LT is already defined. And out.chart. This time I'm going to using data2. They're still using a bar chart. Okay, and in terms of encoding, so as we see, you have to specify for the JSON format, have to specify the attribute type. And we can start this by trying not using it. We say X equal to A, and then Y equal to Y. Okay, and we can run this. Okay, and you can start see actually it's not happy and it has some error messages here. Da, 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 da. Okay, wow, I didn't realize generate this much. Okay, and so actually the most important thing is probably the one at the very end. It says X encoding field is specified without a type. That's exactly what we did here. We said X, just say X. I didn't say what the type of X it is. And it says the type cannot be automatically inferred because the data is not specified in a pandas data frame. Okay, so that's exactly the problems we mentioned. So to fix this, we have to specify the data type. Let's say the X will be ordinal, so that will be capital O, and the Y will be quantitative. Okay, and now we run this fine. We get the same chart as before. And similarly, you can change this, can swap the axis, or even say change the mark, which actually, and I can just do it quickly. For example, if I use small case O and Q, I just want to test if it works or not. Okay. And it seems to be complaining again. Yeah. So it does not recognize small letter as a data type. And again, okay, so now it's okay. Okay, and so it looks like if you're using pandas, and you can write slightly less code as you try to infer the data type for you. Okay, and then you can also import the data as a URL. So this is for the, and if a data set is available online somewhere, then you don't need to write the actual data inside your code. And this is quite useful, especially when the data set is not as small as, say, this. So this is just sometimes people call them toy examples. And it's useful to explain how the code works. But in the real world, the actual data usually will be much bigger than just 4 rows and 2 columns. Okay, and so this is the data set we are all familiar with. This is called the cars data set. And if you remember, and it has maybe 300 or 400 rows and maybe 20 columns, something like that. And you certainly don't want to list the data in your code because they're going to be way too long and make it much harder to see the actual code because it's just going to be dominated by a spreadsheet of all the data. And so instead, so we're gonna be able to use that as a URL. So this will be inside the Vega dataset, which is external library, and it has the dataset provided by Vega. Okay, if you remember, and so Altair is a Python implementation of Vega Lite. And if you remember, Vega Lite specifies the syntax and many other things. And it also provides a few common data sets and you can use in the visualization. And so these are all included in the Vega dataset. So we're going to just try a part of the Vega dataset called data. Okay, and so then the difference here will be, say, URL equal to data.cars. And so the data here is the data here. I'm kind of using the cars dataset, and you need to know what is available and in the Vega dataset and to know the different ones and names. And the cars is one of them. We're going to see a few other ones later as well, and say .url. So that gives URL of the car dataset from the Vega dataset library or package. And then you can do the same or very similar. You say Altair and .chart. And in this time, you're including the URL. You don't have a data object or data frame, and you just a URL, which is also fine. And you say mark point, and then encode. Okay, and you map to the X and Y axis, and then you need to check to know the exact name of the attributes so they can reference to. So in this case, the X is mapped to the horsepower and the Y is mapped to the miles per gallon. And then you also need to know the data type. In this case, both are numbers. So you put Q, it's quantitative. And you have to make sure, say, the capital or underscore are exactly the same. Otherwise, it will not be able to match the okay, so I just show you quickly. Let's just want to show you very quickly what the Vega dataset look like. And so it's a repository on the GitHub. And all I did, I just Googled Altair Vega dataset. And if you go there, you can see this one here. And the dataset is actually inside this folder and the data, I believe, yeah. And then you can see, so, okay. This data is actually this data here. So from the Vega dataset, which is the top level, we are importing data, which is, sorry, that's the Vega dataset, which is this one. And here are the different data sets available. So we are importing this one, which is the cars.json, and you can importing other ones as well, like airports, Anscombe, which is very simple example. And if you click on that, you can actually see what are the attributes available for each class. And you have to make sure you're using exactly the attribute name in your code. In this case, we are using horsepower and miles per gallon. If you look at here, we have horsepower and miles per gallon. You can use any of other attributes, but you have to make sure and they are exactly the same spared and say using underscore, say acceleration, yeah, etc., etc. Okay, and you can use any of these data sets that's available, and we're going to use some of them in the rest of the lecture. Okay, and then the other thing, to run this, and you have to make sure your computer is online, and this is actually loading a data set from an online server. If your computer is not connected to the internet, it will not be able to get the data set, and it will give you an error when trying to visualize it. Okay, we're going to come back here. and do this as well. Okay, and so we need to remember this already. Okay. 3 import to data cards. Okay, so this is getting the data. So first we can import the data library from Vega dataset, and I'll now name data3 to a particular URL for the cars and run this. Okay, and it's happy. And we actually now creating the validation. And this part should be familiar by now. Now with the dataset source, we're going to using this data3. Actually, yeah, maybe it's better just call this URL and just make it. And usually the more descriptive or matching the names are better. We're going to using a point marker, and you can actually see these are different markers you can use available in Altair. And you can have point, area, bar. We already tried point and the bar, and there's some other many different other options you can use. Okay, and we're still going to stick with the examples here. We're not going to using bar because there's a lot of data points. If we're using bar, they're going to be too many and overlap each other. And then encode. Okay, and you have the right encoding. And as already seen in the data set, and this data set is actually stored as a JSON file, and each of them. And in the previous slides, we mentioned if it's a JSON file and the Altair cannot infer the data type automatically, then you have to manually tell it what it is the data type. So I have the horsepower as one word, and the data type will be quantitative, which is number. And the y-axis is going to map into miles per gallon. And okay, I'm going to run this one now. Yes, I expected it to not work. It says, okay, it says name URL is not defined. Because I changed this to URL and it didn't run again. So I have to run this one again first and run this. Yeah. And we're still having some errors. Okay. It says horsepower Q encoding is specified without a type. Okay, so it looks like because I add a space between the column and the Q. Let's try this. Okay, and delete this one as well. And let's run this one again. Okay. And there's still a problem. So it doesn't really show anything at all. Okay, and that's actually the errors are actually included deliberately a little bit early. The previous two errors are not deliberate. So here, it has to be a capital G. That's how the data is. And if we try this again, you've got all the data. Okay, so this is something actually you have to be very careful. As you see, when I was using the small g, and it cannot find the attributes, and as a result, it does not draw anything, but it does not actually give you any error information as well. That's not particularly helpful. It doesn't really help you to tell what causing the problems. So you need to be extra careful when you're doing this. Okay, and so here we showed you can using URL to load the data, and so I can't really show you when it works. And without the internet connection, it should give you error. And if I stop my internet connection, you will not be able to see me at all. Just want to check in terms of timing wise, how are we doing? I think we already take quite a bit of time. But I have to speed up a little bit if we want to cover everything. Yeah. Okay. Yeah. Sarita also mentioned the capital G. Exactly. Very well spotted. Okay. We're almost halfway through, so I might have to speed up a little bit. We're only on slide number 6, and we have 40 slides to cover. Okay. Including the index data. And so this is something very specific to DataFrame. And DataFrame by default would have an index, and you can sometimes even specify a column is an index in the DataFrame. And then by default, Altair does not including the index, but you can include if you want to. So this shows examples, and it uses NumPy. So that's another very common Python package. And so you can see it's import NumPy as NP, and it's using its random number generator in NumPy to generate a series of random numbers. And so you see pandas, we're creating a frame, a data frame, and the values would be the random generated series numbers. I think that means, I don't know how many, I think it's probably 100. And you can add an index to the data set as well. And in this case, pandas.data range from 2018, frequency is staying and period is 100. Okay, and then you can see this is a data frame, and it has, this is the index because that's what's set in here. And this column or the values are the random generated numbers done by this. Okay. And in this case, if you want to visualize this information, you need also the index here as well, which is essentially the dates. Okay, and then to do this, I'm not going to. Okay, so to use index, you need to explicitly turn the index itself and into a column and using reset index. So this is the data we defined before. In this slide, you can see this is the data, which is pandas data frame. And you say dot reset index. So that turns the index itself into a column. And its name actually just called index. And then you do the similar as before here. We're actually using a line as a mark. We're doing a line chart. And it says encoding X will be the index itself. And T stands for temporal data, with a capital T. So we want to treat these values as dates or time in general, which will be a better way. And then the value, which will be this column we defined here, which is this one here, and its type will be quantitative. Okay, and then as a result, you will see a line chart like this, and the x-axis was mapped to the index, which is the date, which was formatted correctly as year and months. Okay, yeah, as I said before, so if the index object does not have a name attribute, and it will be called index by default. That's why we're using the index here. And the type of T stands for the temporal. Okay, and again, so this is actually more about the pandas data frame rather than say Altair itself. For a data frame, and you have two common forms to store data. And one is called the long form, the other one is called the wide form. And for the wider form, the data has one row per independent variable, and with metadata recorded in the rows and column labels. Okay, and we'll see that in examples later. And the long form has one row per observation with metadata recorded within the table as values. So the examples we've seen so far is mostly the long form. Anyway, which is the form that is best working with Altair. And so usually we want to convert the data into the long form and then make it easier to visualize in Altair. Okay, so here we have these examples. And so this is so-called wide form, which is a bit different than we have seen so far. And you can see we have the data attributes and its value actually including all the dates inside the data set. And you have Apple, which one is one of the, okay. And this AAPL is shorthand for a stock, and which stands for the Apple stock. And it says AAPL. And these are the three values for these 3 days. And then there's Amazon, and that's Google. Assume this is their stock price for these different dates. And you can have this. So you can see the first row is for that date for the Apple, Amazon, and Google. And so each row is one time, and the metadata for each observation is the column. Okay, so what you are having here is essentially for this row, and you have the values for Apple, Amazon, and Google. So you have 3 different values. These are not like, say, 3 attributes of the same thing. It's like 3 different things. Each of them has only one attribute, which is the stock price, if that makes sense. Okay, and so usually, if you do it this way, and the matrix itself will be wider than normal, than the other form, the long form. So the wider form essentially means it's usually wider, or each row is usually longer. And you can see, and for the long form, it's a bit different. Now each row only shows the price of one stock at one time. And so you'd have the date and the company and then the price. And then again, next date, the company, and next, it's the same company and next new price, etc. And you do the same again for Amazon. And you can order these rows differently. For example, you can say you have the August 1st price for Apple, and then you have August the 1st price for Amazon, August the 1st price for Google, and then followed by November price for Apple, etc., etc. And then in comparison, if you look at this one and this one, you can see here each row is not as wide because it's only including the price information for one stock. But as you imagine, it will have more rows because now each company would have 3 rows instead of total 3 rows as the previous ones. Okay, and so as we already mentioned before, an Altair works best with this long format. So this is a preferred format for Altair to handle compared to this one. Okay. Yeah. So for example, if you use the long form data set, which is this one, we defined it here. Okay, you can see it has a date. And then for each date, you have the company, and there are some repeated values because for one company, you can have multiple dates. And finally, the price. And the price is actually the values we need. And then you can map easily to each of the attributes to different channels in the validation. And so we have 3 attributes here, which is date, company, and price. And then we can say we're going to map date to the x-axis, price to the y-axis, and then the company to the color. So this is what you got. You can actually have 3 lines. That's the date, that's the price, and that's the color. And obviously, and you have to also specify the date types as well, which we're going to cover soon later on. Okay, and we're going to actually, I think we can just try this and in the actual code. Let's go here. Okay, let's exit full screen here. Okay, and let's add a new cell. Okay, I'll define the long form. Just being a bit lazy, so I copied all the data from here. And also I use this print long form, which would then kind of display all the data from here. So I have these 9 rows from the data set, and which are the date, company, and then the price. And then we do here, do the actual visualization now. And so we say Altair, in this case, do LT. Or we're using the chart function. The data here will be using this pandas data frame, and we'll call it long form. Long form, and we are using mark, and in this case, we are using line. And most importantly, and then we'll do the visual encoding. Okay, and the X will be date, and you can see that will be this date here. And we want to specify this data type is T, as you said before, as we saw before, you can't have a space between the column and T. Okay, Y, we're going to map to price. Again, you just have to make sure it's exactly the same as it before. Why I keep pressing that? And then the color would equal to company, which is N. I can't remember now. Okay, and the other small thing you have to remember here, you have to use color, the American spelling color, not the UK one. And if you use UK one, it's probably not going to work. Yeah. And it says encoding channel is not recognized. Okay, it's only recognized American spelling. And run, yeah, and then you got this visualization. Whereas if you using the long form is actually not that not quite possible to do this, because if you come back here, this is a wide form, and you have date, Apple, Amazon, and Google, and then you have these 4 attributes. You can't say map Apple to X coordinates or to Y coordinates. That's not what we really want. What we want is actually to see the price change of the Apple stock over time. That would make it harder to do if it's in the wide form. Okay, and you can convert between the two, and I'll say, and you can visualize using the layering. Okay, and layering in a sense, you are drawing multiple graphs. and then including them in the same single chart, and each graph or as a one chart, each graph as one layer. That's called layering. And usually, so that means you have to actually specify the violations 3 times, something similar to this 3 times, one for each of the layer, in this case, each of the stock prices, each of the companies. So usually that's not as convenient as just say using ones and chart to do it. So yeah, and you can do this and just converting from wide forms to long forms just done inside pandas, or it can using in the chart itself, basically using Altair to do this. Okay, and if you want to do this in pandas, and there's a method called melt. Again, this is just part of the Python pandas. It's not part of the Altair. Okay, and so I'm not going to do this now, and I'll just say this is the wide form, exactly the same as we defined before. And then you can see here we're using the melt, and it specifies the different variables. And in this case, it says variable name will be equal to company, and then this value equal to price. So this will have the variable name. Sorry, and yeah, and this will be the value. And the first row will be the date. And then you have the company and price. So that's what it does. Okay, and similarly, you can achieve something similar in Altair. Ooh. And this is something called fold transformation. Okay, and you can see Altair and dot chart. We are loading the data. We say wide form, so load this as before. And before we do the mark and encoding, you use transform fold. And you transform these 3 columns into company and price. Okay, we don't really have time to cover a bit more details, but essentially it'll give you something and very similar to this format. And then the rest will be from here will be the very similar as before. And you specify the marker, which is a line, and then define the encoding. And the X will be the date. So this will be the dates from the original data. And you have the price, which is the ones you set here, and the color company is what you set here. Okay, and okay, you can use either of these and in your work. Okay, and we're gonna go through this part and fairly quick on it now, just because we're kind of a bit behind in terms of schedule. And so Altair and has some building functions to generate data. And so this is similar to, say, the random generator we saw before. And Altair has some building functions to generate data. And one here is to generate a sequence. Okay, and you can see Altair and it's run sequence, and it has some parameters similar to a random number generator. Okay, and then you can use that to generate a sign. Okay, actually, this sequence is it generates a numbers between 0 and 10, and each step is 0.1. So every time increase by 0.1, and this will be the X. And then when you actually join this, you would say the X-axis will be just this, which is the X. You can see X, and the Y will be this, which is sine. So basically, that's the sine value of the X. So I'm treating the x as an angle and then calculate the sine, which you got this kind of wave. And also you can actually generate a sphere and using the geoshape function inside of the Altair, and which is one of the unique things in Altair. Again, just because of the time, and we're not going to cover in too much details here. Okay, now we're going to move on to the encoding part. If you remember, we have two parts to start with, the data and encoding. So that was the data part. We could talk about, say, the different and import data as a frame or as a JSON object, specifying the type of attributes and also the long and wide forms and how to convert between them. And now we're going to talk about encoding. I mean, as we already talk about, I mean, this is concept the same concept we talked when we're covering the Tableau part. And all it does is map the data attributes and to visual properties or the channels. Okay. And we have done this quite a few times already because we have been using the char.encoding method all the time, or the function that is doing the encoding. Okay, and so there will be some predefined channels that you can map to, and the one we use the most are the X and Y, and also we use the color as well, and there's a list of different visual encodings. We'll see a little bit later on. Okay, yeah. And again, also we talked about this before, and for pandas data frames, and Altair can automatically determine the type of the attributes. Okay, and so that's a bit convenient. And to say, this is also important to create the scales and legends. And for example, if it knows it's on the x-axis, it's a number, and it knows what is minimum and maximum values, etc., etc. And if it's a categorical data, it's on the axis, and it will create the different labels for each bars, for example. Okay, and so this is still the car data set we had before, or at least very similar. And here we still mark each date point or row into a point here. And so we already done this before. We had X as horsepower, Y and miles per gallon. Now we are using two other encoding channels. One is color, which would map to the origin. So we can see it automatically generates this legend on the side because you don't need to specify the types. And then also the shape is mapped to the origin. And then Altair will automatically generate 3 different shapes, the circle, square, and triangle, and map to the origin. And so this is more just for demonstration purposes. We are mapping both the color and shape and to the same attributes. This can be useful sometimes, for example, if you want to emphasize that information. But in many cases, usually, just one of these will be enough. For example, if you map the origin to the color, might be sufficient. And again, this relates back to, if you remember, the list of different channels for either quantitative or categorical attributes, and they have different effectiveness. And so here you have 2 options or 2 channels to map the same categorical attribute, which is origin, and you can usually should choose the one which is usually more effective. In this case, I believe it will be the color, and it's more effective than the shape. But again, you just need to refer back to the slides we covered earlier on. Okay, and so and these are the different channels you can use. And obviously, we already seen the X and Y. And the actually Altair has X2 and Y2 defined. So you can have a second X value and second Y value. So the examples, for example, the second x values can be used to and used in the error bars to show intervals. Okay, and similarly, the y2 can be used to show the confidence intervals for the line chart. So this is actually has a more and complete list on the Altair website. And if these are the links you can click, actually, it will allows you to see the examples. No, it's not listed here. I might just show you quickly because we will not have time to go through each of these ones. So it's much better if you just have a quick look. And if I just Google Altair encoding, what that's called, Altair encoding channels. Well, I should find the correct one. Yeah, okay. And so you can see that's one here. Oh, this is a bit different. This is slightly a different version of the Altair now. So the document has been updated as well. The one we were using was 4.1, and so this is 4.2 now. And RC1 means release candidate 1. That means it's going to be released very soon. And then, so you can see how to use the second X2. And in this case, it's actually specifying the start and ending positions of each bar. So for each bar, you not just only has one value, you have two values to specify the X and starting and ending. That's why you have the X and X2. And similarly, you can do for the Y axis. Okay, and you can also have longitude, latitude. These are treated differently than just X and Y. And if you'd like to find out more of these, just go to Google and Altair encoding channels, and you should be able to find that. Okay, and there's more channels. So these are all just positions, and these are, and then the next one will be the other channels that we can use. You have the color, the fill. Okay, so that's you can fill the mark. And just very quickly, so here we set the color of the mark, and then you can see all these marks are actually hollow in the sense the color is only on the boundaries. In the middle, it's empty and there's nothing there. And so that's a separate property, and which is a fill. And you can set that to the same color. Sorry, you can set that to the same attributes or something different. It's up to you. And just one more channel that you can use in your validation. And then for the fill, which is the color inside each mark, you can set opacity as well. Sometimes you do not want to make it completely opaque. That means you cannot see anything behind it. You want to give it make it less opaque. In other words, it's a little bit transparent, and so you can see overlapping effects, etc., etc. Okay, and then there's the shape, the size, and all these ones are fairly standard. And then the stroke. I think it's just to say it's a different type of lines you have. If you look at here, go back. Stroke, we don't even have any specific. And I think the stroke usually just means the width of the lines of the mark. So if you come back here, and for example, this one mark is a rectangle, and the line width of this rectangle itself you can set with stroke. Okay, you can also have text. And essentially, if you have a text, it will give you the labels. And just be careful, for example, in this data set, oops, And if you turn on the text, and then can be too many because each mark would have a label, and you can imagine they're going to be overlapping each other. I actually made it harder to see rather than helping the validation. Okay, and sometimes maybe the tooltip will be better, and all you need to do is just same as before, is the tooltip, and you map to certain attributes in the data set, and you can even adding a link URL to somewhere online, say a web page or something. Okay, and then so that's for the different channels. And if we remember, we need to specify the attribute type in some cases if it's not in the pandas data frame. So we have been using these shorthand, and also we have been seeing Q, which is for quantitative, is O is for ordinal, and N is for nominal. So that's the categorical value, and T is for temporal, and then G is for geospatial. So this is mostly for drawing the maps. So in the book, really, we only covered ordinal and quantitative, and then nominal. So nominal will be called categorical in the book. So these are three types we covered. And then in here in Altair on bigger light, and temporal is treated as a special type. It has its own type, and which is T. Okay, and so far, the way we specify in the data types is the so-called short form. And this is what you have this for. And you have a column and followed by one of these numbers, one of these capital letters, and the Q, O, N, T, or G. And most likely it will be one of these top four. You say the acceleration is Q, that means it's a quantitative, it's a number. And this one is N. N stands for nominal, that means it's categorical attributes. Okay, and so this will be the long form. Okay, and so for the short form like this, there's only so much you can specify for each channel. And sometimes you have to specify more than two, besides what attribute that is and what type is. There's some other things you want to set for a particular channel. Then you have to use the so-called long form. Okay, and first you have to say out.x. Excuse me. And so this is the equivalent of this, and here it says out stands for Altair, and this X has to be a capital X. So it maps to which data attributes and type equal to quantitative. Okay, so the type equal to quantitative is the equivalent of doing this. Okay, and obviously currently there's no benefit of writing the long form, and obviously this will be shorter and does exactly the same job. But you can imagine for in this long form, and you can actually add more. You can have another dot and set another attribute to a different some values, etc. That's 3 or 4 different attributes, or even more, which will not be possible to do in the short form. I think that for the short form, you can have up to like the specified attributes and the type. Okay, and then similarly for Y, and you have the name and the type equal to something, something. Okay, yeah. Okay, so the data types also have an influence on the color scales that automatically chosen by the Altair. I mean, you can also manually specify the color scales. That probably would and require a bit more code. And usually Altair would automatically generate color scales for you in most cases. They are actually okay. So here, and the most important part is whether it's a discrete or continuous data type. Okay. Again, just because of the time, I'm going to just go through this without actually writing in the Visual Studio Code. So you can see we're creating a chart. We're using the cast data with the mark is point, and here the encoding. And the x-axis will be the horsepower, the y-axis will be the miles per gallon, and this will both will be numbers. Okay, these are all the things we have done so far. It doesn't really matter, and so we are familiar with this. This is just setting. It sets the visualization size. It says the width is 150, height is 150, and that's the size of the chart. Obviously, you can change this, and usually there will be default value set by Altair. Okay, this is where things starting getting a bit different. So here, saying in the first chart, the color would be the cylinder. So the number of cylinders a car engine has. And the first one, you treat it as quantitative value. And by default, this means numbers, and it means it's continuous. So by default, Altair will choose a continuous color scales for this. And in the second chart, we still use the same attributes, but we said this type is all, and all means ordinal. So it means it's you can still order them. The example of ordinal data type will be, say, the dress size. You can small, medium, large, but you don't. It's not continuous. There's nothing in between small and the medium. You don't have, say, halfway between small, medium, etc. Okay, and as a result, the Altair would choose color scales, but these will be the multiple steps of the same color, not a continuous one. And finally, and if you set this data type to n, which is nominal and which is categorical, so categorical by default does not have an order. So you can see what Altair did is just say pick 5 different colors for different values. Then this, because essentially it treats it, say there's no particular order between them. And sometimes maybe this will be useful, but can be a bit confusing in this case because it actually is a number and has some orders. Okay, and similarly, the data type also has an impact on the axis. Okay, and these are fairly subtle ones. So if you look at the here, we are using a population data set. We set the size of each picture, which is not critical here. Okay, and you can see for the first chart, the x-axis mapped to the year, and the year is treated as a quantitative attribute. And in the second chart, still the year mapped to the x-axis, but now it's ordinal. So the difference was the quantitative is continuous and the ordinal is discrete. And you can see, and this is the difference. So first, this is quantitative. You can see it automatically add some space between the bars. And also you can see there's missing value here because that particular value doesn't exist. Whereas here, if it's ordinal, it doesn't, by default, it does not have any space between the bars. And also this missing values, it will not show. And because they just put one bar next to the other, it doesn't really matter. I think the missing year is actually 1890. But because it does not treat this as continuous one, so you will not have this kind of effect. Okay, and hopefully we can finishing this in just in time. And there's other things and you can control, for example, including the axis properties, the scales properties, header titles. And if you're creating a histogram, you can control the binning, the size. or aggregation, for example, and calculating the mean, average, sorting, and many other different things. Okay, and so we're going to see one example, and which is creating a histogram. Okay, and so here, okay, I hope you all know what the histogram is. So you have a value range for one of the attributes, and it will count the number of data rows, data items within each specific data range, which is called the bin, and shown here. So for this, it says the horsepower is between 40 and 240, and between the range 40 and 60, it has, let's say, 18 cars. So that's this bar. Okay, and so the way you specify this visualization, you say Altair, and chart is cars, that's what we've seen before, and you set the mark as bar, and then encoding, so the Y will be the count, so that's counting the number of things, and it only makes sense because you do this part. Okay, and this part, we cannot say X equal to something, something, and because we want to set this as a bin equal to true, and that's not something you can done in a short form. So you have to say out the X and max to the horsepower, and then bin equal to true. So here, it only says I want to do binning the values based on X-axis. I didn't say how many bins I want, or maybe the width of each bin, etc. So these are all done automatically, which you can set later on. Okay, and you can bin not only on the X-axis, and you can do this on Y-axis as well. So you can see it binning based on both horsepower and miles per gallon. Here, the number of cars within each range is now mapped to size. So pick the circles and give you, means there's more cars within that range. So this is like a 2D histogram, if you, but instead of using, say, bars, we're using circles here, and you can change that to other type of mark. Okay, and then you have the count and average, and there's some other things which are all very similar. You can have the maximum values or median values, etc., etc. Okay, so this is, again, we covered before, and you have this shorthand and the longhand, or short form or long form of writing the visual encoding for each of the channels. So this is the most common one. We have seen this many times, X equal to an attribute name, and that's the shorthand for alt.x, an attribute name. And you can also include in the attribute type, instead of have to write in type equal to quantitative. And you can also including one of these aggregation functions. You can say sum or min or medium or average something. Okay, so that's the shorthand for this. You can specify the type of the aggregation results as well, say quantitative. Okay, but to say, as I said before, when you need to specify more than actually this one is already 3, more than 3, and then you have to use the long form. You have to specify more. There's only so much you can do with the shorthand. Okay, and this is one of the maybe the more complex examples, most ones. And you can actually also ordering the marks in some way. And so, as we already covered in the lecture, and this is called the stacked bar chart. So essentially, for each of these bars, it's made up of a number of, in this case, 6 small bars, and that's one stacked on top of the other. That's why it's called stacked bar chart. And you can control the ordering of these small bars within each big bar. Okay, we are importing Altair. We are getting the data library. Okay, so this particular data we are using is called the barley. So that's some of the bar. I don't know actually exactly the context. Okay, and so you do the chart. It's going to load the barley data set, which is this one. The mark will be bar, and then do the encoding. Say, okay, and the X will be the variety, which is one of the attributes, and it's numerical. Sorry, it's nominal. That means categorical data that's usually needed for the X bars. Okay, and then the Y is the total of the yield. Assume yield is another attributes in the data set, and it's quantitative. And the color equal to site. So these different colors means the different place. Site usually means place. Again, this is nominal, it's categorical. Okay, finally, this is the ordering part. So you order, and again, so this is similar to the long form. You say outer.order, similar to outer.x or outer.color. So this we're going to mapping to the site. So it's going to be using the site order, and the sorting order would be ascending. And so you can see these are the sites and ascending. So start with alphabetically C, D, G, M, U, and W. And also this is also sorted here, and will be the C, D, G, M, W. So this is how do you do the sorting. Okay, and this is another one, and here it's a line chart to show the changes. Oh no, it's a line chart. And then you can sort the orders of these points. So in this case, and you actually order them by year. So this is actually the miles per gallon. Sorry, this is the miles, and this is the gas. So we are using the driving data sets, and we're using line mark, and the point equal to true. So you can actually see these points on the line. The x-axis will be the miles, and the y-axis shows the gas, and they order these points by the year, which is a different attribute. And okay, I think we just got a couple. Yeah, so this is for the last example, and just because we are running out of time, so we'll leave it for you to and look at and after class. But the general idea is you can do the sorting, something similar to ascending or descending, and you can specify which attributes to sort by, and then either in ascending or descending order. Okay, and in terms of reading, that will be, again, as we said, we mostly follow the Altair user guide, and which is what we have been looking at this, and just to make sure you're looking at the correct version compared to what you're using. And for today, it's mostly about specifying the data. That's the data part. And so, and also the encoding part. And so what we covered today. Oh.